talking about segments, specifically measuring segments. Tomorrow will be angles. What is a segment? Well, we already talked about that, right? It's a piece of a line, basically. Okay, so I'm going to give you a distance formula that's slightly different than your book. And the reason is because when we do more dimensions, it'll make more sense. So in the end, it'll be fine. So distance in one dimension. So we are in one dimension for now. We'll get to 2 dimensions and 3 dimensions. And when you do distance, if you do this formula, it's going to make way more sense later. So our distance in one dimension is going to be the square root of x1, that's our first point, minus x2 squared. So x1 is the first point, and x2 is the second point. Now if for some reason you're doing your homework and you decide to use the book formula, that is okay, it is equally correct. Just later understand that you may be slightly confused by what we're doing.
Did we have this formula last year?
Yes. In 2 dimensions, you just add more stuff to that. You just add on to that one. So here's a number line, and that's 0. And let's say this is 2, this is 4, this is 6. Now when you're doing your number lines to graph something, or you're told to make one for one reason or another, number enough of the hash marks that it's clear what your increment is. So if you're going 0 to 10, you don't need to number all 10, the first few. Also, please, if you're going to number going to the right by 2s, then number going to the left by 2s. Don't do them 2 different increments. All right, so let's say I have a point right here. We'll call that point A. And it's actually, you would put it on this number line right here. I'm just putting it up there so that you can see what I'm talking about. And let's say I have a point B right here at 6. So point B is at 6. And I want to know, well, what is this length? What is this? How long is that? And some of you are like, well, I can count that. 2, 4, 6, 8. Well, I want to go all the way. And 10. So it's a length of 10. So obviously, you can count that. You're not always going to be able to count that. If I give you like 1,000, you're going to not want to have to count 1,000 little humps. So use the formula. So let's use it. So distance is going to be the square root. And we're going to take x1. Well, x1 is our first point, so it's this one. x1 is going to be -4. And we'll subtract from that, see minus, we'll subtract from that 6. And then we're going to square the answer. So we need to follow the order of operations. And what is -4 minus 6?
-10.
-10.
Then 100.
And what's -10 squared?
100.
100. And what's the square root of 100?
10.
10. Now, in this case, do you have to use the formula? No, if you can count it, you just look at it and you're like, oh, that's 10, obviously. 10, write it down. Use the formula when it's a larger number, or it's like odd number, something weird might happen. Then use the formula. Don't make life unnecessarily hard. That's good, that's easy. Next thing. Are we good? Do we need another example of distance? Anyone? I'm looking. Distance, we're good. Makes sense.
So
All right.
Leave it out. So you just leave it. Okay.
Can I just leave it? What?
No. So you just leave it like that.
10?
No. Oh, I see. Okay. I
Yes.
got it.
Okay, there we go.
Box your answers, Kate.
Box your answers. All right. Next thing, midpoint. And this one will be pretty much the formula that's in the book. I'll abbreviate it MP for midpoint. That's going to be x1 plus x2 divided by 2. That's going to give us our midpoint.
We know that one.
Yep. So if I have a segment here,
This one's easy.
and this is 4, and if this is the midpoint, what can you conclude about x?
4.
It is 4. X must be 4. These must be the same length. And we use hash marks in geometry to tell if these are the same. So if this has 1 hash and this one has 1 hash, I mean that these are both the same length. Now let's do another example here. Let's put another one. And maybe I tell you this length here, maybe this length is 10. And I put a hash here and a hash here, and I say x. Therefore, what must x be?
2.5.
Yeah, x would have to be 5 in that case. It would be have to be half of that 10, right? Does that make sense?
This seems
Are we okay? All right, we're good?
Box your answer.
Just to make Kip happy. Box my answer. Okay, so that forms the basis of what we're doing today, but we're going to integrate some algebra into this. Okay? So, once I see that everyone is done, now I make up my examples, so if something comes out really weird, that would be why. Alright, so let's say this piece, this is our midpoint, and let's say this piece right here, let's say this is 5x plus 2. And let's say this is 3x plus 20. Here are some questions I could ask. I could say, what is x? I could ask, what is the length of the segment? I could ask that. I could ask, what's the length of half of it? What's the half segment? So your book, your quizzes, tests, they'll ask questions like that. And you need to know which one to do. Often, we just solve for x and we're like, oh, I'm done. Well, in each of these cases, you'll have to find what x is, but you might have to go a step further. All right, so before we do this problem, let's do one more easy example. You don't have to write this one down. If this point right here, I'll call it point M, if that's the midpoint of segment AB, and if this is 6, what's this?
6.
And what's the length of the whole thing? 12. Okay. So what do I know about this and this?
Then you're going to equal each other.
They're equal. So I write 5x plus 2 equals 3x plus 20. Those would have to be equal. Now I solve for x. Who remembers from algebra class what we do first? Victoria.
What you would do is you combine like terms, such as like you'd add, or no, you subtract the 2 and the 20.
We could do that. We subtract 2 from both sides. Sure, we could start there. So on the left I have 5x, and on the right I'm going to have 3x plus 18. Now she said combine like terms. I would have said, well, there's no like terms on the left, there's no like terms on the right. I get x's to one side. That's what I normally like to do. Get all my variables to one side. So what do we do next?
Subtract 3x.
We're going to subtract 3x. Get our variables to one side. I just like to do that step first. But it doesn't matter. This is equally correct. And so on the right I have 18. Last step.
Divide.
Divide by 2. And x is 9. So I've answered the first question. So what's the length of the whole segment?
9.
No. 18.
It's testing y'all.
This is 9 and this is 9, so the whole thing, and half the segment, of course, is 9.
Well, no, that's just saying that x equals 9.
Yeah.
Oh, you are right.
Yeah.
Good job. Okay, good job. X is 9. Good catch. What is the length of the segment? I have to put 9 into that. So 5 times 9 plus 2. So I got 45 plus 2.
47.
47. 47 is the length of the segment. Good job, Jacob. Half the segment, whatever 47 divided by 2 is.
I think 47 would be one segment.
It is one segment.
But you said
Boy,
x equals the whole
I'm
thing.
being a bonobo today, aren't I? This is 94, and this is 47. Woo! If it weren't for Jacob, this class would have just completely fell apart. We're going to do another example because I really botched that one. Anyways, Jacob is correct. What we should have done with this 9 to figure out the length of the segment, we take this and we put it back up here. That gives us half the segment, so 47. And then I double that to get the whole thing. Good job. Wow, he's really keeping me sharp today. Whew. do another one.
Did you not get your breakfast this morning?
No, I did not, as a matter of fact.
I kind of think I'm over here.
It was okay. I was not fed. All right, here we go. Let's do another one. All right, so we have our thing here. And let's say this is 10x minus 4. Let's say this is 6x plus 12. All right, so if this is the midpoint, what do I know about these two things? They're equal. So I say 10x minus 4 equals 6x plus 12. What do we do next, Evan?
I'm just gonna write it down. After subtract the 6x,
Subtract 6x.
then add the 4.
And then, yes, we will add the 4 once we're done with that. So we add the 4 to both sides. So we get 4x equals 16. And then x equals 4. Okay, so that answers the question, what is x? So now if I want to know the length of the segment,
Then you would do 10. Then you would do 10 times 4, which is 40. 40 minus 4 is 36, and 36 times 2, whatever that is.
so we do Justin's implanted. We do 10 times 4 minus 4,
Yeah,
which is
it's
40
called
minus 4,
implant.
which is 36. That's this, right? So I have two of them. The length of the segment would be 36 times 2.
And then the half of it would be 36.
Right. So 36, 36, and the whole thing's 72. Okay, now here's a pitfall that many of you fall into. You assume that something that's on the segment is a midpoint when you're never actually told that. So that changes how you do the question. So let's say, I don't know what I just did there, but we'll go with it. So let's say I have a segment, and I tell you this whole thing right here, let's say that is 80, and then I put a point right here. Maybe it's, now I made it pretty obvious it's not the midpoint, but if I never tell you it's the midpoint, you can't assume it. So this is not a midpoint. And let's say this is 2x, and let's say this is 3x plus 5.
Then you would have found the midpoint, correct?
I can't find the midpoint. Unless I wouldn't even be asked what is the length of the segment. I'm told the length of the segment is 80. I might be asked what is x?
So,
I could say maybe this is segment A, B, C. I could ask you what is the measure of segment AB. I could ask you what is the measure of segment BC. Now notice what I'm doing there with a little m. That m means measure. Okay, so I'm talking about a measurement.
So then for like M measure A line AB or whatever, would your answer be 2x?
I want to get a number, so I'm going to want to use this 80. So this is the whole segment. So let's do like a little example down here. Let's say this whole thing right here is 10. And let's say this little piece here is 2. Then what's this big piece?
8.
8. And if I don't know that, how do I know the whole thing?
Yeah.
I add them together and get 10. So what do I know? If I add these two,
You're going to get
Yeah,
an
you're gonna have to add.
yeah, I get 80. So I'm not going to say 2x equals 3x plus 5 because that's obviously not true. This is shorter than this one. But 2x plus 3x plus 5 equals 80. And now, do we have like terms that we can combine on the left?
Yes.
Yes. So 2x plus 3x is 5x plus 5 equals 80. Subtract the 5,
And that's
divide by
Then you get 15.
5. And we get 15. X is 15. So that answers the question, what is x? If I want segment AB, I put this 15 into that 2x. So 2 times 15, 30. Now I could get this BC two ways at this point. I could take that 15 and put it into here, but faster, take 30 and subtract it from 80 and get 50. Because we just found AB is 30 in this previous step. So then this would have to be 50. Okay? Does that make sense?
A lot of sense.
Okay. In that case, we are done with that part of class.